Alright, hey y'all, it's Miss Summers with your notes today on severe weather. I'm gonna back up here. Here we go. There we go. Alright, so, what I want y'all to take away from these notes today is how severe weather forms and how people can be prepared. Alright, so just like with earthquakes and volcanoes and things like that, it's important to recognize that we're not going to be able to stop severe weather from happening, but by understanding how it occurs in nature, we can better prepare ourselves, and that's going to minimize harm to us, which is a good thing in the end. All right, so let's start by talking about what severe weather is, how we define it. Severe weather is weather that poses a threat to people or property. In North Carolina, where we are, the most common types of severe weather are thunderstorms, tornadoes, and hurricanes. So we're going to focus on those today. All right, in other parts, you might deal with things like blizzards or monsoons, but these are the three that we're going to put our energy towards. All right, let's start with a thunderstorm. What it is, how it forms, what it needs. All right, a thunderstorm generates lightning and thunder. All right, lightning and thunder go hand in hand. Thunder is actually the byproduct of lightning. It's basically just an explosion that's caused when air gets super, super hot from the lightning strike, and then it collapses in on itself. Thunderstorms are also going to produce very high winds and very heavy rainfall, as well as hail in some instances. All right, thunderstorms are a very common occurrence on the Earth's surface. There's literally tens of thousands of thunderstorms that occur every single day. But they don't all happen in the same place, or excuse me, they don't happen equally throughout the world. All right, most of these thunderstorms occur near the equator, towards the tropical regions. All right, how a thunderstorm forms. A thunderstorm requires warm, humid air, which is why they typically occur in tropical areas, because that's where you have the correct temperature and the amount of moisture needed. You also have unstable air. And when we say unstable air, we just mean that the air is either rising really quickly and then falling back down. All right. In a thunderstorm, you have 3 stages. All right. And these are in order, beginning, middle, end. When a thunderstorm first begins to form, you will have what are called strong updrafts. That will supply the warm, moist air that's going to be needed to drive the thunderstorm. All right, you might be able to see the cumulus stage in action. If you ever sit back and watch the clouds on a summer day, if you ever see clouds sort of rising up, billowing upwards into the atmosphere, that's a cumulus stage, or that's the cumulus stage occurring before you. All right, in the mature stage, this is where the precipitation will begin. You'll have those heavy rains, you will have those strong winds, and you will have the formation of lightning. All right, and we'll talk about how lightning forms in the little diagram I'm about to show you. All right, and lastly, the end of a thunderstorm is the dissipating stage. In the dissipating stage, you have strong downdrafts. So we start a thunderstorm by having air rise. The end of a thunderstorm is when air starts to sink more. All right, when the downdrafts overpower the updrafts, that cuts off the warm, moist air that's needed to fuel the thunderstorm, and the storm breaks up. All right, so here's what that looks like in a picture form. All right, here's our cumulus stage, our updrafts, our mature stage where we have updrafts and downdrafts, and then our dissipating where we have the overwhelming downdrafts. Now let's talk about lightning for just a quick second. How does lightning form? It happens in this stage, in the mature stage. Basically what happens, or basically what lightning is, imagine if you take your feet and you were to shuffle across a room that had carpeted floor, and then you touch a doorknob and you get zapped. That's essentially what lightning is. It's a giant static shock. So because you have this constant updraft and downdraft, that creates an electric charge within the cloud of negative charges. Of negative charges, all right? And a quick physics lesson, electric charges, much like relationships, you have opposites attracting. So because you have this heavy negative charge up here in the cloud, a group of positive charges will form on the ground. All right, and these charges want to get together, but the air does not want that to happen. Air is a resistor of electricity. Electricity doesn't like to go through air. But these charges are so powerful that a shock, that electric that connection will be made between these charges. All right, and that is the resulting lightning bolts. All right, if you've ever watched lightning, all right, if you watch lightning form in like really slow motion, you will see it's not coming down from the cloud to the ground. You will have one part of the lightning bolt coming down from the sky, from the cloud, where the positive charges are, or excuse me, the negative charges are. And then you'll have another tail of the lightning bolt coming up from the ground, and they will meet in the middle. So, pretty cool stuff. Alright, here's a diagram. It would be a really good idea for you to draw this. I think it's pretty snazzy. Hint, hint, wink, wink. Alright, thunderstorm circulation. Alright, what a thunderstorm looks like in its mature stage as it's causing damage. Alright, so you have this this thunderstorm cloud, this cumulus cloud. What's really interesting, what I like about this diagram the most is it has this anvil. Right? Anytime you see a cloud that sort of flattens out at the top, that is a sign that a thunderstorm is going to be where you are pretty soon. Alright, so that's a good warning sign. Alright, the other reason I like this diagram is because if you look down at the bottom at the surface, you can see a front. And this is a cold front. Alright, I can tell it's a cold front because there's cold air behind it, there's warm air in front of it, it's going this way. Remember, cold air is more dense than warm air. This forces the warm air to rise quickly. This forces those updrafts to happen. And that's why thunderstorms typically occur at cold fronts. That's why that happens. Okay? So, that's what I need you to know about thunderstorms. Let's move on. Oh, nope, JK, LOL. Again, like I said a few minutes ago, thunderstorms are really common on the Earth's surface, but they're more common in some places than others. Obviously, if you lived in like California, excuse me. Here in California, you have very few thunderstorms per year. On average, fewer than 10 a year, which is kind of crazy. Thunderstorms are going to be way more common over here in the southeast of the continental United States, especially our friends in Florida. They get thunderstorms like literally all the time. They can't help it. And again, it's because thunderstorms require that warm, moist air. Florida is surrounded by warm, moist air. Here in the southeast, you have warm, moist air coming in from the Gulf of Mexico. Remember, this is a maritime tropical air mass, which is why these areas tend to be more prone to thunderstorms. Alright? Cool. So, let's move on to our next type of severe weather, the tornadoes. Alright, tornadoes, you might be like, those don't happen here a lot. They kind of don't, but they kind of do. It's definitely something we want to keep our minds on. So tornadoes are windstorms in which you have air rotating. They're basically rotating columns of air, and that can cause a lot of problems. Most tornadoes form in association with severe thunderstorms. So I'm recording this on Tuesday, April 14th. If you live in North Carolina, which I imagine you are because you're my student, that would be weird if you're not. I mean, it's whatever. On very, very early Monday morning, around 4 a.m., we had a very severe line of thunderstorms move through our area. And I specifically got up to be awake in that time because one of the concerns was that these thunderstorms had the capability of producing a tornado. Now, very fortunately for us in North Carolina, from what I understand, there were no tornadoes in our immediate area, but our friends in South Carolina, unfortunately, did experience a few tornadoes, and they suffered quite a bit of damage, which is never a good thing. Alright, so how does a tornado form? What does it need? If you remember this from the air mass assignment, I had a question specifically about tornadoes, and I want you to write this down. Tornadoes require warm, moist air, and cold, dry air. Now, a warm, moist air mass is a maritime tropical. Write that down. Maritime tropical. Cold, dry air masses, in this light blue right here, cold, dry air masses are continental polar. Continental polar. So when you have a continental polar air mass and a maritime tropical air mass meet up, there's your tornado. There's where your tornadoes are most likely to occur. Alright, let's talk about how it forms. Tornadoes form as a part of these things called mesocyclones, which are rotating air masses at high altitudes. A mesocyclone forms when you have air on the ground or close to the surface. It's horizontal and it's spinning. It's on its side and it's kind of rolling around like a cylinder almost. Alright, stronger winds, alright, shear winds at higher elevations will cause it to rise vertically. Now you have an air mass and it's rotating. It's now called a mesocyclone. And mesocyclones spawn tornadoes. Now, we're not a bajillion% sure what the magic moment is, why some mesocyclones spawn tornadoes and others don't. That's one of those great scientific questions that's being researched. All right, but we know that in order for a tornado to happen, you have to have these things happen first. All right, so here's what that looks like. Here's what that looks like. All right, here's that rotating horizontal column of air. Here's those shear winds picking it up. This is the mesocyclone here. Tornadoes are going to occur when a column of that air drops down and touches the surface. Alright, average number of tornadoes a year. I really like this graph because it really shows Tornado Alley super nicely. This is the average number of tornadoes per 10,000 square miles. Let me see if I can get that thing to go away. Here we go. Yep, the dark red is 9, red is 7, orange is 5, and then we have these shades of yellow. Here in North Carolina, this is where we live in this sort of darker yellow. We may see about 3 or so tornadoes per year within this little range. But really, the majority of the tornadoes are going to happen here in this band of the United States. And that makes sense because look at what is around this. They have cold, dry air, continental polar masses coming down from Canada, and they have warm, wet air masses from the maritime tropical air masses coming up from the Gulf of Mexico. It's literally the perfect place for tornadoes to form. This is Tornado Alley. This is where the storm chasers go. You know, they go starting out in about April, May, and they'll be there till about July, August, and they're looking for storms to study. All right, this is where it's most likely going to happen. But as you can see, most of the eastern United States, you are prone to it. Out here, not so much. You don't have that. You don't have the warm air masses coming over here to form tornadoes in this region. Okay. All right. Tornadoes are measured on this thing called the Fujita scale, not the fajita scale, not the fajita scale, but the Fujita scale. Right? Fujita's named after a Japanese scientist who came up with it. That's why it's called that. It is a 6-stage, or it has 6 different levels from 0 to 5. In North Carolina, I've been living here my whole life, and in the 30 plus years I've been here, most of the tornadoes that I've seen in our area are usually F0 to F1. Maybe 1 or 2 F2s that I can recall. Alright, these more severe ones, F3, 4, 5, they're kind of like the big earthquakes. Like, they're really, really bad, but they don't happen a whole lot. They're maybe like a once-a-year event, fortunately. But they're definitely something you want to watch out for. And even the F0, F1, I mean, even though F0 we say it's light wind, they still have wind speeds of 70 miles an hour. That can do some damage. That can definitely do some damage if you're not prepared. Alright. And our last type of severe weather associated here in North Carolina are the hurricanes. All right, this even though we don't live near the coast of North Carolina, we are in western North Carolina, hurricanes are still something we want to make sure that we're aware of, because it does affect us even though we're kind of far inland. Alright, let's look at what a hurricane is and what it needs, and I just realized this is misspelled. Please don't correct me, I understand. Alright, a hurricane is a tropical cyclone. What a cyclone is a low pressure system. Hurricanes are basically a very strong low pressure system that's very organized. They produce winds of at least 75 kilometers an hour, which is something like 68 miles an hour, I think, question mark, don't know. They're very powerful storms. They are very long lasting. They can threaten large tracts of land along the coast. They can affect environments and humans, which is why it's kind of a big deal and we make a big deal of them. Alright, so how do they form? Hurricanes always, or I should say not always, but usually form near the equator or in the tropics around late summer. And they form then because water temperature has to be about 80 degrees plus in order for it to form. Now, with that being said, do they only happen in late summer? No. There have been hurricanes that form in January. It's very unusual. It doesn't happen a lot. But as long as there's warm water, you can have a hurricane. So hurricanes are these low pressure systems. They will form and they'll be pushed by regional airflow. We're going to talk about climate next week, and we're going to talk about wind patterns. Winds are going to push these along their merry way. And as long as this hurricane is over warm water, that provides the updraft that's needed to sustain the energy. So as long as it's over water, it's going to continue to be a severe weather event. It's not until it either gets somewhere really cold or it gets over land that it will begin to dissipate. All right. So the dangers of a hurricane, what we care about. All right. Flooding from hurricanes is very common because they bring a lot of precipitation with them. High winds can damage structures, so I'm sure we've seen, just look up Jim Cantori Weather Channel, and you can see him in the hurricanes reporting, and the things are all flying around him. All right, those can be very dangerous. And coastal areas, my neighbor's generator is going off, excuse me. And in coastal areas, you can be prone to storm surge, all right? So here's what storm surge is. Here's normal sea level. The winds of the approaching hurricane will push extra water up onto the beach and inland. Storm surge is what does a lot of the damage, particularly in our coastal communities. In like Hurricane Katrina, you had 18 plus feet of storm surge. And that was really devastating because New Orleans, as wonderful as a city as it is, it's a beautiful place, it's a wonderful place to visit. It's built in a bowl. It is very hurricane prone. So that 18 feet of water basically put a lot of the parishes, or neighborhoods, communities underwater, and people, when your house is completely underwater, you basically lost everything. Alright? So, how are hurricanes measured? They're measured kind of like the like tornadoes. Tornadoes have the Fujita scale that goes up by wind speed. So do hurricanes, but we call it the Saffir-Simpson scale. So a hurricane is either a category 1, 2, 3, 4, or 5. And obviously the bigger the number, the scarier it is. And you're like, oh no! I added this chart not because I need you to memorize it. Like, obviously, I don't need you to memorize, but definitely know how to read it. But what I wanted you to see was the difference or the relationship between wind pressure wind speed and air pressure. All right, in a category 1, the wind speed is going to be between 74 and 95 miles an hour. Which you might be like, oh, it's only a category 1. 95 miles an hour is still pretty dang on fast. But this has the highest pressure in any hurricane, over 980 millibars. The worse the hurricane is, so like if you get to a category 5, where you have sustained winds of over 155 miles an hour, which is not something you want to ever experience, you have the lowest air pressure, all right? The lower this air pressure gets, the worse this hurricane's going to be. That's why we want to know what's happening. Remember, friends, when air pressure decreases, air is able to lift. And lifting air equals bad weather. That is not something you want to deal with. Alright? Cool beans. Okay, so again, usually by the time hurricanes get to us here in the western part of North Carolina, depending on where they make landfall, it's usually down to a tropical depression or a tropical storm. It's very rarely a hurricane by the time it gets to us here in Charlotte or Iredell or wherever. Alright, but these are still pretty substantial winds. Alright, and they can cause damage. Alright, people, we experience hurricane fatalities, alright, from time to time. And I think it's because people don't realize that a hurricane, the effects, even though, we associate it with a coastal, it's something that affects our friends on the coast, it can still affect us here, and we need to be aware of that. Alright, now speaking of awareness, making plans for severe weather. I'm not going to go through all these links. I'm going to let you do that. You have an assignment. I put it on yesterday's. Wow, Miss Summers. On tomorrow's link on Fridays. Your assignment, you're going to do a little bit of research on some severe weather events. And part of your assignment, I want you to make a plan for a severe weather event. Either a tornado or a hurricane. And these are some links that can help you with, what should I do if there's a tornado approaching? How should I prepare for a hurricane event? Things that are going to keep you safe, keep your family safe, keep your friends safe, all that good stuff. Alright? So if you have any questions, you know how to get in contact with me. I look forward to seeing your severe weather assignments. I am super excited about those. Hope y'all have an excellent day.